Hello, my people. Hope you're doing well. This is video 4, and in hindsight, I probably should have just tacked this on to the end of video 3, but whatever. Doesn't really matter. As long as the information is there and you guys understand all this material, how it actually is, whether it's tidy online is of little consequence. So, what we're going to do in this one is we're going to need to we figured out how to solve, right, quote unquote, the oblique triangles, meaning finding all of their angle measurements and their side measurements given a certain amount of information. What we also need to determine is how do I find the area formula how do I find the area of an oblique triangle? Now, this is the law of sines, and there's an area formula. I mean, this section is called the law of sines, and there's an area formula that involves sine as well, and so they're kind of grouped together. There is another way of arriving at the area of an oblique triangle, and it goes with the law of cosines. It doesn't have cosine in it. It's actually it's called the Heron's area formula, and we'll talk about that when we get there. But this one actually, and Heron's area formula really doesn't have anything to do with the law of cosines. It's just sort of tacked on there, I don't know, for symmetry's sake. But this one actually does have a similarity because just like when we were devising the law of sines, I'm going to drop this height right here, this perpendicular altitude. And the reason I'm going to do that is I know that area is going to be, like my area needs to be 1/2, in this case it's actually B is my base, isn't that interesting, times H. What we're going to do is we're just going to find a different way to represent H. Okay, so that's where we're heading. Okay, well let's talk about this angle A over here. I know that sine of A is H over C. And that means that H is C sine A. And if I use that, I can actually plug it into my area formula and get 1/2 BC sine A, where C sine A is just plugged in for H. Well, let's look at C right here. Sine of C is H over A. Okay, and H is equal to A sine C. So that can be plugged into my area formula. Area is equal to 1/2 AB sine C. Well, you don't have an altitude dropped such that you actually can access, for lack of a better word, angle B. But if you were to, just like in the law of sines, if you were to spin this around and drop an altitude here and create another H, you could do a little bit of substitution and you would find that the area is always, basically, the area formula in terms of sine is always 1/2 side times another side of the triangle, okay, times the sine of its included angle, meaning the angle between those two sides. So notice that it's AB sine C, BC sine A. It's going to be, the area is also going to be 1/2 AC sine B. So basically, anytime you're dealing with this area formula, what happens is, let me see if I can illustrate this a little bit better. Let me get out a piece of paper real quick. Okay. Okay, let me... Okay, I'm trying to make those as symmetrical as possible. Or kind of, yeah, as congruent as possible is what I meant. B, C, and so this is A, this is B, this is C, C, A, B, C, A, B. This area formula basically works if I have A, B, and angle C, if I have B and C and angle A, or if I have A and C and angle B. That's when this works. This works when I have two sides and their included angle. That's what I meant by included angle. The angle that those two sides become the initial and terminal side of the angle. Alrighty, well, let's stop talking about this in terms of abstract concepts, and let's actually do a problem or two. What do you say? Okay, and there's the area formula as we see it, as we find it in Larson's book. And so if we want to actually do this one, we notice we have B and C and the included angle. I mean, it really is this simple. The area is going to be 1/2 of BC sine of A. And that means it's going to be 1/2 20, 40 sine of 48 degrees. At which point we're going to get a decimal approximation, because sine of 48 degrees doesn't give us a nice tidy a nice tidy value. So times 20 times 40 times sine of 48, and what I'm going to wind up with is 297.258, and it's going to be feet squared. Okay, so there you go. Okay, let's do one more. I notice I have A, I have C, I have the included angle. I need the area 1/2 AC sine of B, which is 1/2 62 times 20 times sine of 130 degrees. Now, this of course doesn't have units on it, so you don't really have to include units. If you feel compelled, you can put units squared. It doesn't really matter. Let's do 1/2 times 62 times 20 times sine of 130, and I'm going to get 474.948 units squared. I mean, it really is that easy. This, of all the things that law of sines is one of those things that's really, really helpful in terms of computation. Its dividends for next year are not huge. This area of the oblique triangle, however, you will see this next year. You will see this in calculus. And the assumption is not only that you have learned it, but that you remember it properly, and can pick it up and use it strategically when necessary. And I'll clue you into kind of when that happens and when that's necessary. So this is the last week, and I usually don't do this on the YouTube videos, but since nobody was in class today, let me go ahead and detail kind of where things are headed in the next few days. Basically, Monday and Tuesday is 6.1 law of sines, and of course your week 5 quiz is due tomorrow. Please do complete it on time if you can. Wednesday and Thursday is going to be 6.2, which is law of cosines, and it has an area formula as well called Heron's area formula, or Hero's area formula. It actually pops up, the guy's name pops up both ways. In terms of things that have been proven and are famous proofs, Heron's area formula is one of those ones that like shows up in popular math books. So it's incredibly well known, and I'll give you more details about that when we get around to it. At some point, guys, I know I've been lenient on when things have been turned in over this summer course, but decisions have to be made as to who is recommended to go into calculus and who is not recommended. If you don't have anything turned in, then I can't recommend you to go into calculus. If you've made really poor scores on everything, I can't recommend that you go into calculus. Unfortunately, it's not one of those things where I can do a whole lot of hand holding. It really is a course that has its own pace, and the pace is going to be my pace, which means that if you have deficiencies in understanding, or you have a lack of passion for being in calculus, and you don't find it interesting, it's not really your jam, then that's fine. I mean, you don't like not taking calculus tells me zero about your character. It just tells me that you don't want to take calculus, and that's fine. You're not, it's not a bad thing to take statistics or college algebra instead. But if you are serious about being in calculus this coming year, and kind of you want the challenge, you want to take the AP exam, you want to see if you can pass it, you want a ticket to the show, then I'm going to need you to pound out the rest of this stuff. Show me that you have an understanding of it. Show me that you have a little bit of the determination, because if you're either lacking in understanding or determination, calculus is going to be it's just going to be a year of frustration for you, and I don't want that for any of you. I do want as many of you to take it as possible, but I also don't want to talk anybody into it and have them be incredibly frustrated for the rest of the year. So what we need to do is I need you to turn in everything. If you're interested in going on to calculus, turn in everything as soon as possible so that I can get it graded. I can pass that information on to the administration. The administration has moved heaven and earth over this summer. They have been working tirelessly to figure out all the logistical things that are necessary for us to be back on campus. And the sooner we give them a list of the people who are capable of doing calculus and who desire to do calculus, the easier that's going to be on Miss Watson and the rest of the administration. And I want to respect her enough to get that stuff to her in a timely fashion. So there's going to be a cutoff date, at which point I'm basically going to assess you based upon what you've turned in and make a recommendation based on that. I hope that didn't sound harsh. It wasn't intended to be. It was more of a matter of fact. Here's where we stand kind of thing. If you have any questions on the content of this video or basically what I'm looking for in terms of my recommendation to move on into calculus, please do shoot me a message. I'd love to chat with you more about it. Again, I'm looking for as many of you as possible to come and to take calculus, because I do love having a full class. But on the other hand, like I said, I don't want to frustrate anybody. And so, sit back, have a moment of introspection, figure out where you stand. Let me know. Okay? I will look forward to hearing from you, and I'll look forward to seeing those of you who are capable of showing up to our online class tomorrow. And we will discuss law of sines and its area formula for a second day. Bye.